Hello everybody and welcome back to more of the 2017 Fermat paper, and we're up to question number 22, which looks like it's going to involve some three-dimensional geometry. A cylinder has radius 12 and height 30. The top circular face of the cylinder is the base of a cone, and the center of the bottom circular base of the cylinder is the vertex of the cone. Okay, they're being very specific here. A sphere is placed inside so that it touches the cone, the base of the cylinder, and the side of the cylinder as shown. So we've got definitely some points of tangency here. Which of the following is closest to the radius of the sphere? And we have some options. Okay. So as I say, three-dimensional geometry, and I'm often quick to point out, I'm not the best at visualizing three-dimensional geometry. However, I find with a lot of questions, you don't have to do three-dimensional geometry. I mean, if somebody comes along and says, this plane is intersecting this cube, you might need to have a little bit of more intuition to see, oh, this is going to form a regular hexagon or something. Oftentimes I find, and I think it'll be the same with a question like this, if we just view it from the side or from the top or from the bottom in just the right way, we can get one or possibly a couple two-dimensional pictures that will allow us to use our two-dimensional geometry skills to answer this question. So, let's see. Most of the action seems to be happening down here with this sphere. So I'm going to draw a side view. We don't have to. I mean, we could do a top view, but I think the top view is basically going to look like this. And then you get the center of the cone. You don't really get the action of the cone interacting with the sphere. But if I turn it on its side, suddenly the cone becomes a triangle. So first things first, we're solving for the radius, right? Yeah, it is the radius we're solving for. So we're going to give the radius a name. Let r equal the radius of the sphere. Alright, now let's draw a side view picture. Which is basically what they gave us, but there's, has some three-dimensional. I'm not going to draw it with a nice little 1230, because I really just want to focus on that sphere. So let's draw the sphere. As a side view of a sphere is just a circle. There we go. So it's tangent to the sides and the base and our cone here, which is just going to be an isosceles, I think, triangle. And the cone touches in the middle. And we know that we've got a height of 30 and cylinder has radius 12. Okay. So 30 and then this distance here is 12. Okay. Now, we have a bunch of tangencies. So let's get those in there. So tangent to the sides. And viewed from the side, a cylinder is a rectangle. So we get a right angle there. When radial lines hit points of tangency, it's always at right angles. So we got little r's here. And we actually now have a little square that's r by r. And then we have another point of tangency up here. And that's really the only interaction between the cone and the sphere. So that's something we're definitely going to focus on. So we need to get equations involving r, I would say. Definitely need equations involving r. So if I have an r here, and I know this whole distance is 12, then the distance from this point to this point is going to be 12 minus r. Okay. What's that going to do to help us? Well, I suppose this distance here becomes 12 minus r, because we've got a point out here outside the circle, and both of these are the two tangent lines to the circle, so it's the same distance from the point of tangencies to that external point there. Now, if that's 12 minus r, we haven't actually used the cone yet, so let's, from this point of tangency, what I can do is I can drop a full right angle here, and we've got 12 to 30, so all of these are going to be in the ratio of common factor of 6, of 2 to 5. So, 2 times this will be 5 times this. Yeah, something like that. 2y, 5y. Okay, so maybe we can... Actually, maybe we should have something named there. Problem is, I'm just going to be introducing another variable. No, it's not 5, it's 2x, wasn't it? Actually, I think I said 2y. I don't know why y crept in there. But, suddenly I'm introducing another variable and I don't really have... I can get r in terms of x, I guess, but what else can I do? So I'll get rid of that for now. I like this right angle. We're definitely using parts of the cone. So I think we should... Having that 12 minus r there is kind of annoying. Because, okay, so say I call this 2x and 5x. I'd then get one equation. I could relate the x's to the r. I get one equation, but two unknowns, and I want to solve for r at least. So I need sort of another equation here, and I'm just not seeing one. But that's what's going through my head. That's why I'm not proceeding. That's why I'm hesitant to add this x, because yes, I'll be relating x to r, but I'm trading one variable for another, and I'm not seeing if that's gonna... I don't see yet that helping me. Is there more geometry that I can exploit? Well, suppose we just extend this guy. So I don't want to extend it all the way over, because then I'm got this little gap here that's leaving the circle. And I can't control that gap. I mean, if I understand r, then yeah, I can understand that gap, but maybe if I get a right angle there. Because then I've got a rectangle. And I can relate 12r up here, but I'm going to draw this half of the circle a little bigger just so I can get a better idea of what's going on here. That's not so bad. Okay, that is kind of bad. We'll get rid of the line and redraw it. There we go. So I don't actually care about half of this cylinder. So we cut through the point of tangency, and then lo and behold, we get a nice little rectangle. And then we have r here, we have r here. Now, we have a right angle here. So the problem is, what do I know about this new right angle triangle? Because I could start calling it x's and y's and z's and things like that. But what can I really do? But we have a right angle here. So if I call this check and this x, check plus x has got to be equal to 90. But check and x, that means that this guy down here must be x. And so we get that this is check and that these two triangles are similar. Okay, they're not congruent, obviously, but they're similar. So if I started labeling instead from the smaller triangle, just so that my functions are getting bigger, call this guy x, and then suddenly this is 5 over 2x. And then this is 12 minus r, because there's r here, and it's 12 in total, so 12 minus r minus 5 over 2x is this length right here. And then if I multiply that by 5 over 2, I get this height here, but I already know that that's x plus r. So I think, and then either using the 12 minus r as the hypotenuse, or probably more likely the r as the hypotenuse, I can get another equation relating r's and these new x's, not the old x's. So I think that should do it. That gives me two equations and two unknowns. So x squared plus 5 over 2x all squared is equal to r squared. That's going to be 4 over 4x squared plus 25 over 4x squared is equal to r squared. R squared is going to be 29 over 4x squared. And I don't like that 29 there because it's not going to have a nice square root. But I suppose we could have r is root 29 over 2x. There we go. So, but probably going to want to actually have it as 2r over root 29 is equal to x, because I'm going to get another equation thanks to the similar triangles, and it'll have x's and r's, and I want to substitute in and solve for r, not for x. So we'll rearrange it there. And then what have we got? We've got 5 over 2, 12 minus r minus 5 over 2 x is equal to x plus r. Right? 5 over 2x, because it's in the ratio. 30 over 12 is 5 over 2. And then the whole distance is 12 minus r, so now we need 12 minus r minus 5 over 2x. Alright, so I'm going to multiply by 4 on both sides. Do I want to multiply by 4? Well, let's multiply by 2, and we'll get 5. 12 minus r minus 5 over 2x is 2x plus 2r. But it's nice that this one right here is going to be linear. So we get 60 minus 5r minus 25 over 2x. This is why I wanted to multiply by 4. So we'll multiply by 2 again. So 120 minus 10r minus 25x is equal to 4x plus 4r. Alright, and then 120 minus 14r minus 29x is equal to 0. Or I guess I should say 129 is 14r plus 29x is equal to 0. So now we know what x is, so it's 14r, oops, don't need this equals 0 here. 14r plus 29, 2r over root 29. So those will cancel out. Now we'll get 14r plus 2 root 29r. 14 plus 2 root 29 r is equal to 120. So r should be 120 divided by 14 plus 2 root 29, if I've done the math correctly. So now we get out our calculator because they said is closest to. So 14 plus 2 times square root 29. I get about 24.77 something or other. We'll reciprocal that and multiply it by 120. And we get 4.8445 something or other. So this is approximately 4.84. Did they have 2 decimal places or just 1 in the question? 2 decimal places, and I'm getting that it's 4.84, so A will be my answer. Okay. So not a bad question. I mean, the 3D geometry had me a little scared, but side view and it became two-dimensional geometry. And wasn't so bad a question as long as we did notice, well, at least I needed to notice the similar triangle. Maybe there's another way with some circle geometry that I'm just not seeing. But, yeah, there we go. So that was question number 22. Join me in the next video for question number 23. I'll see you there.